Okay, here we go. Number 1, use the information provided to write the vertex form equation of each circle. Oh no, it's a parabola. Will do. Okay. First step, move the constant. First step, move the constant. Second step, GCF. Now, what do I need to GCF on this problem? -1. Beautiful. Okay, now I have 10 X tiles. That breaks into 2 equal piles of 5. Okay, now this is where you're going to realize that you might have gotten that second multiple choice question wrong. What do I do to this side? Yes. -25. Yes. Because it's not really 25. After you distribute, it becomes -20. Okay. Now factor using the outsides of the box. And then move the 5 back over. Enter. How many transformations are there in this problem? 3. Okay, once you're situated, scooch yourself down to number 5. Okay, so first thing I do is write these 3 things. Then I write the original, which is 2 times the cube root of x. And then this is going to be 2 times the cube root of -x. Okay, so what happens if you cube root a negative number? What's the cube root of -8? -2. So it becomes negative on the outside. You can kind of see right there that they don't match though. Oh man. Okay, now if you guys could grab a graphing calculator, get it out of your bag or go grab one. We're gonna cheat slightly here. A little bit of cheating. Okay, but I do have a question for you before we start kind of cheating. What are A, H, and K in this problem? What's A? What's H? 0. And what's K? 0. Okay, so A, H, and K are 0, which means that the inflection point of this cube root graph is located at the origin. Okay, so I mean, that's not really shocking to you after we cheat. I just wanted to talk about it before we started cheating. Okay, what do I mean by cheating? Well, I'm going to go to y equals. I'm going to look at the picture and clear out anything that's in there. And I want to remind you that to find the cube root, you hit the math button, but I want the 2 in front first. So I'm going to hit 2, math, scroll down to cube root, and then X is right next to the alpha button right there. Okay, so after you get it typed in, hit zoom, which is the top middle button, and then 6. Zoom 6. That'll make sure that all of us have the same window of our calculator so we can see what it looks like. Okay, and that's wonderful and helpful and all of that. But now I want you to hit second graph. It actually makes the table for you. I didn't want to tell you all this because I wanted you to do math, but it will do the table. Okay, so what we're going to do is we put 0, 0 in the center, and then we're going to do 2 points on either side. So 1, 2, -1, -2. Okay, now I want to give a shout out to Sebastian because he was the only person in the class who was able to actually relate what odd functions do in coordinates. I want you guys to look at the coordinate patterns. Now, I almost marked you wrong because you did not check the origin. And you even went to spot for the origin, but you didn't check the origin. But I asked ChatGPT, and ChatGPT told me that if you can establish the pattern in a few coordinates, understanding that it's a polynomial, then you can probably assume that it's off. No, I wasn't happy because you didn't do the origin. You had a spot in the table, the origin, but didn't check the origin. Anyway, he was the only person out of my classes that noted that the points have symmetry, but they split sides. So, which was super cool. And by the way, that's how you do this in pre-calc too. So on pre-calc, you have to verify even, odd, or neither with the definition, but then you also have to state the coordinate patterns. So he's ahead. But anyway, okay, but just a cool thing. All right. Any questions about that guy? Did you have fun graphing? I thought it was fun. Making the table on the thing. I've unleashed all your power now. Like you can make all the tables on the graphing calculators. Okay. Scooch this aside and let's look at the stamp sheet. So tonight's homework is CPM, problems 10, 11, 12, and 13. Remember, that means through. But this problem is actually a mixture of solving equations. And you guys are going to do this problem on whiteboards. So you can put everything away. You probably want a calculator. I'm going to take my table numbers back while you're putting your stuff away. Whiteboards. We're doing whiteboards today. You don't need to write anything in your notebooks. Okay, you guys, I just had an excellent question about what to do with your chapter 2 packet. In this class, when we're done with the packet, just check Aries to make sure that it's correct. And if it is, then just leave the packet at home. You don't have to carry multiple packets with you, just one at a time. If everything looks correct in Aries, then you're good. If something's not correct in Aries, bring your packet over and I'll fix it. Okay, anyway. Okay, so number 5. And if you're listening to this recording, that's probably because you're absent, and that means that you're going to have to do number 5 on paper. But everyone here gets to do number 5 on whiteboards. Okay, here's number 5. Let me see if I can. Okay, so what you're going to do is you're going to send people, grab one of these whiteboards, and you're going to put it on top of your table. So you each like have a portion of it. You're going to grab one of these for your group as an eraser, and then just grab a few markers. By the way, if you find a marker that does not work, please just throw it away. I have the answers. So you guys are going to do them, and please don't have one person do each one. That is just highly going to irritate me. Just stay on the same problem, please, until I check you, and then you're going to go on to the next problem. This is all we're doing, so take your time. This is it. And then when your group is done, and I'll stamp you, and then you can work on it. All right? Okay.